Thank you very much for the kind introduction. You know, when you're an old professor, you need to look at the clock because otherwise you just drone on and on. So you can tell by my age that I'm close to a software fossil. There's still a few of us left around. We've lost some really great ones who I had the privilege to work with. My background, for those who, I don't think most of you don't know me, is I've spent all my life in software basically excited by the applications I work on more than the technology, although I am a passionate technologist. But to me, the wonderful thing about software is you could go and work with people in all sorts of domains, from biology to engineering to banking. Oh, maybe not banking. I do know a little about the Vienna business opportunities. You know, I could learn a lot from those people. So really, I would go there and learn all about this domain, and it was really exciting, and that it was also reusable. So just as a thing to start off with, the biggest thing we're missing for software developers is their lack of domain understanding. In the old days, and still one company I've worked with fairly recently, when people come into the business, they actually teach them about the business. And they invest a month or 2 to 4 months in doing that. And that means that the developers actually can use the vocabulary of the business. And this saves burning out hundreds of product owners, right? Because you get this Agile worm that's a feature, right? And because the developers don't understand the business, they have to cut it up into little pieces, and the product owner has to feed it to the developers one at a time because they can only do Java. The other thing is a leverage for business opportunities, if you're interested in doing a new startup, is not in technology. It's in taking that technology and doing some magic with it, delivering an amazing experience, as we heard this morning, in the domain of the business. So I want to emphasize that domain understanding is very, very important, and that's one of the reasons people are very interested in DDD, but DDD is not the way to learn about the domain. It's a way to look at the domain that you're working in. So one of this, you know, I've been able to use a lot of actually it was a customer in Vienna many years ago. He says, Dave, you shouldn't talk about this as a weird technology. You should call it an exotic technology. So I've been able to use a lot of exotic technologies and practices, very fortunately. And I've been able to do that because I worked with people who had money and had a big problem. So, you know, the buzzword is, show me the pain and I can show you the gain. The customers I worked with had excruciating amounts of pain, usually due to a really ugly code base. Also to some dysfunctional management and people not knowing what's going on. It's very hard to be a good product owner when the executives in the company don't understand how a bank works. So I really love working on legacy code. Everybody hands up, I want to work in legacy code. Good for you, I want to talk to you later. I can show you how to make a lot of money quickly. So legacy is a place where every young grad wants to go work. Because it's so exciting, you can use new technology, new practices. You can find out how to apply the socio-technical systems you learned about this morning. And you can make a big difference because you're going to actually cross one of the biggest gaps that you have in a business, the age gap. Those who have the experience to you who are very smart, very capable, and probably a little too arrogant. So, of course, when you hear there's another legacy, and it's called modernization now, I don't know that that sounds much better, but and I really appreciate the talks this morning. They all great contributions, and thanks to Squire for organizing this great event. I know how important these events are to communities. I organized the GoTo conferences and the Yale conferences in Australia. We always did it because it meant so much to us as people in a company for learning. Well, we tried all these things, and of course, we know what the answer is, right? You need to be agile when you're working with a legacy, right? Everybody accept that? Well, If you haven't seen Michael Feather's new 15th edition, you want to order it. Still working with legacy code. Folks, all of you need to stop using the word refactoring. You're lying. That's what you told the boss with a smile. We're just going to refactor it. But it's not equivalence preserving. You have no tests. It's not a refactoring. It's a rewrite in disguise. And rewrites don't work. So this whole notion of making a substantial difference in a short time that's meaningful to your business is, in my experience, a false promise with a few exceptions. Most of these projects go on and on and on. So the reality is that this is just a Scrum or Agile death march. Aren't you keen to do a stand-up meeting? Why the hell do you need a stand-up meeting every day? Is your communication that bad? The people at the top are the people doing the serious refactoring. They're just diving off the cliff in frustration. So, in my experience with our customers, we found we really needed something different. And I never thought this was really that different because it's just the way we worked. But some friends and co-speakers said, Dave, you should maybe talk about this. I said, I don't think anybody cares. Everybody hates legacy anyway. And besides, I make good money from it. Why would I want to tell other people how to do it? So what I'm going to talk about is something I call legacy innovation, which most people think is an oxymoron, right? Legacy means no innovation. And look at these young people, they're excited because they're innovating. Innovation is a real adrenaline. So what I'm going to do is first introduce you to Maria. She's an amazing, distinguished heritage engineer. You know, heritage engineering, you take a beautiful building and you renovate it so you have an even better space to live and work. Maybe we should call legacies heritage. And Maria has a crack team that does these. It's a very small team, so we're actually talking about something already that's probably an oxymoron. We're going to have a small team work in a big company and make a difference. What a crazy idea that is. Now, Maria's been so successful that she spends most of her time, at least 6 months a year in the Caribbean, and that's from her villa in the Caribbean. So now you want to apply for that legacy job. So let's talk about what this is. First of all, it's a lean process. Lean is basically the thing that invented all the Agile ideas, but they were too complicated for Americans to explain, so they had to reduce it to things like Scrum and you may detect that I'm a Canadian because I have a sense of humor. So the important thing here is we want to find something innovative, which is high impact, can be delivered quickly without disrupting production. Simple problem, right? And the Bible for doing this is a book called Flow, which is, if you read it and understood it in the first reading, I want to meet you. And most people have to read it like 3 to 5 times. It's basically a study of flow and in particular queuing inside of systems. And Don did it for non-software systems before and then found out, hey, I can resell all this to software people. Amazing speaker, amazing book. And the shocking thing is very few people actually look at the queues in their system. So we do these things called value stream maps. And you find the places that are expensive or bottlenecks or hotspots, whatever you want to look at, and you identify the ones that would really make a difference. And you sort them by most important, not terribly difficult. That's the place to start. And to do this, use these value stream maps, which basically just show you how long things take, and you get the delay in the work, you can do them for other things. And then what you want to do is you say, okay, I've identified each hotspot or each of these places where I think I could do something. Is there some way that I can do this quickly, cheaply, and get it done which doesn't involve too many people? That eliminates a lot quickly, as you can imagine. But basically, there's really sort of 4 classes of these. The first one is a business innovation. That's by far the easiest. No code change, just change the business works. That's often possible, but often not asked. Another one is basically, and one of my favorites, is use better hardware. Hardware is super cheap compared to programmers. I'll do an example later. I mean, you can do a lot with hardware. Then you can try software technology, and finally you can try software practices. Personally, Agile doesn't have a promise about productivity. The Agile promise, unless Jeff Sullivan was mentioned earlier this morning, but I don't think anyone actually believes in this hyper-productivity stuff anymore. The Agile promise is we'll be predictable and we'll have quality. That's it. So what that does is take companies, in my experience, who can't get anything done and makes it so they can barely get something done. And they're still on the death march. So once you've identified something, then the trick is, how can we get this approved? We've identified this change we can make, which has got significant value. It's got tangible, measurable goals. It's got short delivery. It's got minimal operations impact. Already it's sounding completely impossible. And of course, the first thing we do is do a proof of concept. The second thing we do, which is the really important one here, which most people don't, is proof of scale. Proof of concept, MVP, everybody knows you can do those. There's some new, really bright young person and some senior person who wants to see that bright person succeed, so they tell you, you can go ahead and use whatever new technology you want. You can write it in Zort or use the Blotzo framework. And they can build something which doesn't scale very quickly. But the danger is, after seeing a small problem being solved, and Nick mentioned this just earlier, unfortunately, they go ahead and deploy it. Look, we built something with 6 microservices talking to each other. None of them are asynchronous, but asynchronous is easy to add. Just add distributed, David said, just sprinkle it on top. Then you can get to go back and redo it all over again. I know whether you saw David's slide, very important. Microservices, back to monolith, back to what we should have done. That's a very, very big and expensive slide. So the real thing here, since there's a lot of risk and value associated with this, and you're getting executives to sign off on a very significant, potentially hugely disruptive thing, what we have to do is a proof of scale. So we have to show that it will run with the production load, the production constraints. And that, by and far, is the most important thing. And I would say that's the biggest thing I see even with people adopting new technology. They don't actually test the thing at scale. So if there's one lesson, basically, do not settle for a proof of concept for anything. Make sure it works at scale. So when we get these lists of concepts, we don't actually start with the code. Code is really hard. It changes too often. And most of the stuff on legacy code is about code. Now, there is code that's really important, and we do have to refactor it, rewrite it, whatever. But it's data that's really the corporate goal. And typically the data is the thing that's flowing along if you look at these processes. So what we really want to do is focus on the flows and data stores. There are also very easy points to intervene. You can insert something in a flow very easily. So that's fairly easy to not disrupt it. You can split a flow, put something through a new process, keep going with the routine transactions to the same process. So they're much more, data is much more stable than code. Oracle hasn't changed its database page formats in 30 years. They're terrified to do it. So most data is very stable. And most of it's got a simple description. Like reverse engineering data is not very hard. You just usually pull the schema. I have to worry about how they encoded things and compressed bits and smash them down, but it's still fairly straightforward. And the queues are often associated with the data volume. So data is the place that we always start. And I have to say, most of the biggest benefits come from changing the data flow, not from changing the code. Of course, there are code opportunities. There are hotspots. Typically, these are points of high variability or change, which often there's lots of bugs with, or delayed releases because they're changing the same thing, so you find sick modules there. And the only way to fix a sick module is to put it out of its misery, shoot it, rewrite it, and replace it. But that's a module to rewrite, not a system. The other thing is you find things that are highly structured. It starts off and there's 10 rules, and then pretty soon it's 200 rules, so you've got this case statement that goes over pages, and then they say, well, we can refactor that, so they split it up in 2 different kinds of case statements, so it goes over more pages, and the whole point, you're thinking the wrong way. There are techniques for taking things that are highly structured, and they're called table-driven techniques, which are very old but still work very well, and I'll show a couple examples later, that allow you to do this. And then the other thing is you find places where you've just got a bad algorithm, where there's really, really hot code. And so those are places where we then say, okay, we are actually going to essentially rewrite these, but in a small amount of space, a small module. So in practice, we're looking to deliver in these implementations a quick new approach to deliver value with a small team of people. Typically sort of the Agile, 7 plus or minus 1. The 7 plus or minus 1 is an urban rumor too, if you go back about that whole thing, but once the story gets out there, everybody believes it, so 7 plus or minus 1 is a good number. And what I want to do is just take some time to talk to you in the rest of the talk about some different industries, just to illustrate that this isn't something that's industry specific and that you use different techniques at different points in time. I want to make it clear, none of these things is based on any of the people, Maria or Maria's team being super smart, geniuses, right? They don't, they didn't get a PhD from, Vienna University or anything like that. They're just people who think out of the box and think differently. And in particular, what they try and do is an old engineering principle called keep it simple, stupid. Right? What is the simplest thing that we can possibly do to make it work? Which is probably the best principle in XP, along with test first. Refactoring is a promise for refactoring. Ward and Kent Beck and so on are all good friends of mine. Refactoring is something you're supposed to do every few days, so you keep your code healthy. Technical debt is use refactor to reduce that down. If you want to see the original definition of technical debt, go read Ward's. But this notion that the Agilista have is what they do is they basically run like crazy delivering features until they then go, oh, we've got too much technical debt. What you have is software that's written without any design or thinking, right? And feature-driven development, where you produce hundreds of features a day, is complete insanity. And I'm sure that in Vienna you're much smarter than those folks in California who think it's great to produce 100 or 1,000 features a day. So many 10,000 features per month, I saw published by some California. What the hell is the value of those features? Can anybody even talk about them? What's the most important feature we put out last year? Well, I put out 200 that were all really great. Sure. And the features are so small, and then the feature interference gets together, and then you have to you get merge conflicts because, unfortunately, you use a repository that's file-based, not feature-based. If it were feature-based, the features could weave together in the code base. But anyway, so just to illustrate, since I really can't, I do these talks all the time and do different examples. I've chosen to pick some very well-known Austrian companies and their executives, thanks to ChatGPT. So this is a Paywise. They basically do payroll for global businesses, and they take care of the actual worrying about your insurance payments and your retirement plan and everything like that. Well, I don't do the retirement, sorry. And they have these challenges. Basically, the way it works, they have a lot of companies, and particularly you'd be sensitive to the fact that, when you have large unionized groups, as you do in Central Europe, there's a negotiation process, and you sit with the negotiators, and the negotiators and the unions decide what the next set of benefits and payments are going to be. And this is a complicated process. And the amazing people who actually help this actually sit at the back of the room, and they're analysts, and they put the entire business contract agreement into Excel. Because in the end, it has to be automated. Like in America, there's a great rule that says, if you live in Colorado, then you get the first day of hunting season off. There's thousands of really goofy rules like this that are negotiated in these agreements. So the problem they have, that they have a mainframe system. It wouldn't matter if it was a cloud-based system. Same problem. Big system already existing, and they program in an existing legacy language. There's actually 100 developers working on this. And what they have to do is basically, they get this spreadsheets from the analysts, they turn that into code, and that gets deployed mainframe. Unfortunately, because of the complexities of these agreements, they're always late, and they often have defects because, believe it or not, there are sometimes bugs in spreadsheets. They don't crash usually, but they have bugs. So Max, very concerned, talked to his IBM buddy. So I shouldn't name a company, but it doesn't really matter. IBM, CSC, Accenture, they're all terrible, basically. They send you consultants, don't finish, and then walk away and come back 3 times because they take it, well, you didn't put enough money in. Why we don't use companies like Squire and the people around here instead of wasting so much money on these big companies, I don't know. So the first thing is IBM said, what you need is to use this new OO language and to use something called XP. And we have 2 of the people who invented it coming to you. And we're going to just give you those, and that's going to, we think that'll solve your problem. So they actually took these legacy programmers, retrained them in the modern OO language, showed them the XP practices, test first and so on. A little hard to do because the data isn't there, right? And they've got to deploy to a mainframe, and mainframe's only accessible under very strict rules and so on. So can't quite do TDD, but you can practice. You may. And so they did that, and of course the Agilista, the XPers, well, this is going to be great. We're going to show big company in America or Austria, wherever it is. And they did get a productivity increase, about 15%, which is significant to the bottom line if that's true across them. However, they had no change in the defect rates, and they had no continuous delivery. So the answer is, this is not worth the time. Now, these 2 consultants, one being the OO expert, the other one being the XP expert, were a bit depressed because they assumed, well, give them XP, we give them this. What do we do? And just before they left, it's always you get those ahas. Only in failure do you learn. And they realized these people really have a language. It's called the spreadsheet. So the first thing they did is they wrote a rule. One of them went off and wrote a rule checker in that wonderful OO language, wrote it very quickly, a couple of weeks, and it would find bugs in the spreadsheets. So this sent the spreadsheets back to the analysts, and the analysts would fix them, so they were much happier. This reduced the defects significantly. The next thing one realized is that, well, these spreadsheets are really just constraint tables. There's a very simple technique. You do a topological sort of the data flows, and basically you can just take this code and you can just put it in as data. I'm a big fan, by the way, of if you can make something data, please do, and get rid of the code, because data is very easy to version, it's very easy to deploy. It's much easier to work with than code, and not enough people think about making things data-driven. So now they've got these tables compiled. Someone says, Well, if we have the tables compiled, they're just data. We don't actually have to go through this complicated load-build process. We can just write them into a file on the central computer. Wow. So now we've got continuous delivery. Oh, but we have to evaluate them. Well, as I mentioned, simple topological sort. You write the evaluator once, it's a very small piece of code, and it works. So you have to there's some specialized skills here. There's an OO program, rule checker, so you need to back those people up. So you need four people to maintain those two systems. 100 mainframe programmers can be reduced to 10. The cycle time is now almost instant. Very simple example of how moving from something that was a really hard, difficult problem. And the savings from that you can calculate yourself. Done in weeks. All right, well, let's talk a bit about the insurance business. I'm sorry, I should mix it up a bit, more boring insurance, and you'll be asleep here in Vienna. So this is an old established insurance business, so they too have a centralized system, and they've just paid, I actually know the name of the company, XYZ, one of those three that I mentioned earlier, $200 million to rewrite the system. Most of the analysts we talked to didn't actually see anybody from the company. They turned the system on, and the people who sell insurance lobbied everyone up to the CEO and the board to turn it off. They turned the $200 million system off 2 months later. These things happen all the time, folks. The bigger things are, you get we can't let it fail problem. Because you need to fail in the small to be successful in the large. So they wanted to reduce, they said, okay, what we need to do is go SaaS. There's an international competitor that does everything with SaaS. They're very clever at how they do their targeting. I don't have time to go into the details, but it's very interesting. We want to reduce our development expenses, however, by using existing components. For insurance, there's a thing that computes the ratings for your insurance. So there's rating engines. There's a bunch of these pieces. I'm not going to worry about the details. So we want to be able to use those pieces so then we can just focus our development efforts on doing the actual insurance itself, life, home, commercial lines of insurance. However, that's still a big job. Particularly, it also turned out that they decided they were going to do this with Agile and Java because they had a new CIO who wanted to be Agile in Java. That's often the way you get to a new technology. Pick the wrong person and let them take you down the hole. You too believe in the tooth fairy. Okay, so the first thing, and they also had no developers that knew Java. Oh, you can train them. Well, that's a lot of training. So the first problem is, how do you get people that have non-agile processes to work? There was a lot of time spent with the lawyers to explain to the lawyer that an automated acceptance test was actually something that was real. They did not understand, why do you need automated in there? Because if it isn't, you'll never know. So what we did is define a process where if the company gave us automated acceptance tests for their component, we would pay them earlier. If not, they could friggin' well wait until we'd had time to actually see whether it worked. That's typically the way it works. For example, at IBM, if you're a Class A vendor, you follow a process and you have complete transparency to your testing, and the customer gets to run the tests and everything. If you're not, you're Class C, you wait. We also defined a common integration API. Each vendor, of course, we want to do APIs. They're the new cool thing. So they had, hundreds of APIs, the API field of dreams, right? Give them to developers and hope the applications will come. So we defined one common API where we basically could put everything in a JSON package. So all the variability, because it was much simpler, we could integrate. And then basically, we put in the contract that they had to do automatic. Now, this has nothing to do with software development, other than if you don't do this in the contract agreements, you are completely screwed. So this is an example of a business change that made a huge difference, made it feasible to deliver this system at all. So, how are we going to deal with building all these different lines of insurance? And we actually said this isn't possible. You don't have development teams. You're going to need all these developers to do it based on a team of experienced people who'd built insurance before. But what we found is say this company lives in the Midwest, and so that's a very stable environment. And so these people have been in the company for 20 or 30 years. The business analysts, insurance analysts. And while Accenture was busy screwing up the previous project, they'd spent 5 years documenting all the requirements. They'd captured, again, sorry to mention it, in Excel spreadsheets, all of the decision rules, the state machines, all the calculations for this insurance. But nobody ever talked to them. And further, they actually did scrum groups between them with people crossing over and something like we heard about this morning, reviewing these things over and over again and doing sample calculations with them and so on. So the solution was, oh my God, these people have it all done. All we have to do is figure a way to get it out of these sheets. Same trick, basically first teach them how to, when they had the sheets, they used the maximum number of columns in Excel. So you couldn't even print the things out. So we taught them structured sheet programming, how to cut these things into smaller sheets. And we wrote a generator that generated all the code. So any change in the requirement gets rid of a lot of programmers. Okay, let's move along. So this is process control systems. There's a couple of companies in the world who have a hostage on process control systems. One of them is a very large Mother Siemens. The other one is, I think, ABB in Europe. So the classic problem here is you've got all this, they have super proprietary equipment. You want to see closed systems. They actually take standard hardware and modify the pins on the hardware on the bus and patent it. Not because it actually adds any value, it just makes it impossible to make cards that plug into their bus. This is really nasty proprietary stuff. Proprietary communication, they got their own communication network. They may have used some standard hardware, but they modified that too. Packets are different. Awful business. And of course, the companies are hostage to this. They've got $500 billion worth of this stuff installed all over the world in people's customers' factories. So how are they going to deal with this proprietary hardware and the inability to get a sort of centralized view? Well, the solution, which is a good one, adopt open standards. So move to TCP/IP. To do that, they had to build a custom gateway for which they reverse engineered the company's specifications, and then finally the company broke down and agreed to test it. This is a box that just translates hardware protocol, hardware interfaces, and then software interfaces. They started a standards group to standardize the kind of state machines and the visual language they use for describing these things. They used to be called programming logic ladder controllers. And then they basically webified all the data. All of a sudden now you can consume the data with Websters. You can talk to anything in the factory globally, and your applications are just done by writing things that talk to JSON. The savings here, again, are large numbers of millions. Okay, this is probably the biggest one. I think David mentioned it, so I'll try and go quickly. So MRP is now called ERP, but basically this is a process for planning a whole lot of things, and this company happens to be specialized in doing things like really big trucks and tanks and ships and so on. So they keep track of all the inventory and the planning for this. And at the time, this has to keep track of a lot of relationships in a hierarchical sort of bill of materials thing. So they used something that was a proprietary hierarchical database. They basically have tree structures. And again, these companies, of course, are now sitting there saying, but we want to get a flexible report. We'd like to do self-serve. And right now it's at the point that the company, Austro MRP can't even do its own self-serve because they have to write a custom program that talks to this tree structure database. So that was the first thing. But that wasn't their biggest problem. Their biggest problem was that their vendor, LDB, was basically, they were the only big customer left. So their vendor is dying, and they have no plan how to get their system onto another one, which means they have no way for their customers to get there. So this is what we tend to call a wicked problem. So the first one is very straightforward. Basically, if you only, too many people have too many APIs. You only need one API get. Basically, what we really need is just to be able to have select go right to the network and forget about all this REST stuff and everything else. But, and GraphQL sort of tries to do that, but still makes it way too complicated. But you need to have very simple query APIs. Otherwise, you just keep adding new API. Oh, the customer needs a new API, and the product owner says new API, and somebody says, yeah, 2 months. And you get this forest of APIs. In practice, most APIs are pretty simple. They're just data and data queries. So the way to do this for their product was to buy a ODBC driver from an OEM, and basically when you implement an ODBC driver, on the inside it's complicated because they actually do stuff in the tree structure database, but they're experts. And on the other customer side, it just means you can use SQL. They were done this in a few months, went to the user group meeting. The user group said, wow, we can do our own reporting. We won't cancel, we'll actually place an order for this. So they get some initial excitement. Great. Problem is, you just teased them. Now they've got the real ugly problem. The real ugly problem, they of course were working on how to restructure it by writing SQL queries and take the data out. This is the infamous easy problem. How are we going to do data migration? It's not a problem, that's easy, we'll do it later. Never happened on your project. Data migration's easy, yeah. Come and talk to me when you've actually tried it. So their solution basically just was unworkable. So fortunately, our heroine, Maria, had actually seen this problem before, and there's some published algorithms that go back to 1975 for how to restructure complicated databases. And so the algorithm is very simple. The first thing is, since restructuring code is tricky, instead of actually just writing this and bundling it into some proprietary thing, probably in the wrong language, what we do is automatically generate the source code for the restructuring from the schema. That means you've got the source so you can see there's no magic in the migration tool. The other thing is to get speed, we process the database pages physically because otherwise it'll take years. And the nice thing about this is you can actually convert the database pages on either the source or you can convert them on the target where you've probably got lots of machine cycles because the source is busy. So just move the physical pages over, just take a dump tape, put it on a naked machine that you're hoping to get to, and you can apply the refactorings at the same time because the refactorings are also simple, just relocations. And then you can fix the whole thing up in one pass by just fixing all the links between the index tables and so on. I don't have time to go into the details, but it's a very old idea. And of course, I'm running out of time, so basically, everyone knows that you should never use anything but binary data and batching. If you don't know that, come and talk to me. I'll bludgeon you to death later. How many people don't get it? We want to be instantaneous response to each one of these queries. You believe in the tooth fairy. The only way you're going to instantaneous response is to batch them at 1,000 at a time and then process them. Otherwise, you're going to die with the latency and the time between them. And binary is already better. If you're doing something with JSON, you're paying 10x the storage cost and 5x the cost of processing. Nobody should be logging in JSON. Oh, it's so we can read it. Sure, you can read 10 billion records of log data in JSON. My big toe. The final thing here, which I think is really interesting, is that because this is super scary, when you have super scary systems, you have to do something different. And the trick here is basically to use independent teams. It's called independent, that's often referred to as IV&V, and it's done often on mission-critical systems if you can. And if you can't do it, what the IV&V team does is try and simulate it. So this is the digital twin thing, where you try and simulate all the possible things that go wrong. So they have a shared specification, this algorithm for restructuring, and then they do two different implementations. One's a production implementation that's actually going to migrate the data. The other one's the V&V implementation. Now, the V&V implementation doesn't have to run super fast. It can be written in another language. You want to get, and in principle, it really only has to verify the invariant, so it doesn't actually have to do all the work involved in moving the data. It just has to ensure that the invariant's in place. So what this allows us to have is a completely independently written verification, so when the data arrives at the target, we can satisfy an auditor that, look, all the data is there, and it's all being satisfied with great integrity. Again, all simple processes, all written by a handful of people, make a huge difference in very hard problem. I won't bore you with any more. I think I'm out of time. That's it. I'll mention one last one. This is a cyber analytics problem. Julia Huber had this problem. Basically, she's with a telco spin-off that now sells themselves as a cyber analytics company. They have a huge data warehouse, one of those things where you send data so you can't query it, right? And then they have a big data system that runs Spark, where you can't get the data out fast enough to actually look at it. And it's limited because it's written in Java, and Java can't address over more than 24 gigs of memory, so you can never do anything serious with it in terms of responsiveness. And they have to, cyber analytics, you have to be able to analyze queries very fast in real time because you're looking for botnets, and very complicated problem. It's not like it used to be. So the solution is, okay, how can, your team come up with this? And I said, well, how much have you spent on it so far? Well, we've given large company, something of the order of $200 million. Well, we can do it for 10%. They said, how about 10 of 10%? Or maybe 10 of 10 of 10%. Well, we can't do it for that, but we'll try and get in it. So this is a case where we really opted for quite a radical solution. First thing is, modern hardware is way better than most people have. You can buy a machine with this machine, 4 terabytes of RAM, 256 cores, 10 terabytes of VME memory. You can buy that for under $20,000. You can do a linear search through the database faster than any programmer can do it, with a query tool. The other thing is we needed something that was interactive so we could build these things very quickly. The only thing we could find that was quick enough and fast enough was a vector functional language that's actually fairly popular for a number of people in Vienna, but it's quite cryptic. Right? Vector programming is already cryptic, and this is even more cryptic. But it's super fast. The programs are super small. So the solution is, yeah, that works. We just, it's not usable by normal people. So the solution for that is to put a DSL of some kind on top of it. And again, since these people are used to using Microsoft Access and Excel and various visualization tools, we just basically built those tools so they could, think they're working the way they did with, quote, Microsoft Office, but in fact, they were dealing with things that, so in any cell, you can put 1 trillion rows and work on it, work with the values. So again, delivered in a very short time, very different answer. Well, let me finish. I apologize for going over time. So the important thing is to go and hug your legacy, right? I want to make you better. I want to work with you. And I really only want to change your ears. I don't want to reconfigure your entire body, because neither you nor I want that pain. You want to think lean. What is the simplest thing I can do? How can I leverage one specific focus innovation? And those innovations are always going to be different. They have formed patterns that are similar, but they're always different in every case. And then deliver value with speed. If you do 3 of these in a year or even in 2 years, your career will do this. Because most people in the company don't ship anything in 3 months. Well, they ship a bunch of features. Right? But what you can do is you can make a big impact on the revenue or the profitability or the customer ability to respond to the customer by changing a few things in a few places. That, to me, is really what lean should be about. And I thought that was what Agile was going to be about. But Agile, we should just not talk about it anymore. Thank you very much.
Thank you very much, Dave. Thank you. It was very entertaining. I heard many people laughing, which is unusual for a slot after the lunch break. So
I knew the slot.
Okay. I think we're a little bit behind schedule, so I would allow one question. Who? Yeah.
Make it a killer.
I'm not going to throw it so far. Maybe I give it a try, okay? Nearly.
So you mentioned a couple of times that changing the data is easier than changing the code, but could you maybe elaborate a bit more on that? Because for me, it's exactly the opposite. By definition, you can't change data, and if you do that, you will disrupt all the applications that use that data. So maybe I misunderstood the point, or if you can expand a bit about that point, would be great.
Sure. So I think you will agree that the description of the data and the ability to change the data itself is easier than changing lots of code. You agree that that's true?
Yeah, sure. But
okay.
you disrupt also the application that use the data.
Right.
This is what I mean.
So part of that is that typically you're doing it at a concentrated point, so you can preserve the interfaces at those points. You can split the data for the new processing and the new interfaces, so you can put those in place separately. You can also regenerate the interfaces. I mean, if this is all SQL data, for example, you can regenerate all the queries that do it. So a lot of the time, you're not really changing nearly as much as it. It's really the fact you have to split these tables or change these things, and it's the new things that you're adding, so you're not really changing the interfaces other than widening them. So you basically this gets added to the existing API. Now, this assumes that you're capable of you have descriptions for the APIs or the interfaces. If you don't have descriptions for the APIs, then you have a project before you can do this to actually do that, and that, I agree, is certainly work.
Okay, I understand that make you the life easier to rewrite then the application, but eventually in the end you would need also to refactor the code or to rewrite the application that use the new data, isn't it?
But again, if this is at a point, I'm not talking about we're talking about changing the representation at a particular point where the data representation is particularly problematic.
Yeah. Yeah.
We're not talking about changing everyone's view of it.
Okay. Yeah. Okay, I see your point. That's
but
cool.
I don't wish to dismiss your question. Anything that's easy probably isn't true. So it's just easier.
Yeah, I guess that sum it up well. Yeah.
Thank you.
Thank you.
Okay, thank you once again.
Thank you.